This lesson here, you guys have lots of background. Okay, we haven't done it before. It's not a review lesson, it's a new lesson, but you guys have lots of experience with this stuff. Okay, so what we're doing, we are finding limits. You've done that. We've done that. We had a whole chapter with that. You guys had a test on that. That part is not new. The way we find those limits, I'm going to give you another method to find those limits. Okay? It's called L'Hopital's rule. So sometimes it's pronounced, sometimes you see it looks like hospital or L'Hopital without the S. It's a person's name. They came up with this method, the rule. Okay? So yeah, it's called L'Hopital's rule. Okay? Or a theorem. It's another way to solve a limit problem, right? If you look on the examples, they look like problems we've done. These all look like problems we've done before. And they might in fact be problems we've done before, right? But I'm going to give you another method. This method students tend to like better than the other methods we use. So why didn't I tell you this when we were doing limits? Why did I wait till now to do it? Because you didn't have the proper tools to do it. And you'll see. You'll see when we start talking about this. Okay, so when we did limits, when we tackled any limit problem, what was the first way we always tackled a limit problem? So if it was a limit as x approaches 2, as x approaches -3, what was the first way we always did? Always tried. Plug it in, right? Plug it in, see if you got an answer. If you got an answer, you're done. Move on to the next problem. What were the situations, though? So if we plugged it in, right? If we plugged in a number, there were 3 things that happened. The first one is we got an answer, right? We got a number. Got an answer. And then there were 2 other situations. What were the other 2 situations that happened after we plugged in a number? Denominator of 0, right? If we get something if we get 0 on the bottom, but a number on top, 12 over 0, 20 over 0, right? What would our answer, what would our limit always be? Does not exist, right? It's the same idea as undefined, but does not exist, right? What if we got 0 on top, though? So there's 2 options, right? If you got 0 on top and a number on bottom, that would just be 0. That's number 1. That falls under number 1. The answer is just 0. But what happens with the reciprocal of this guy? Or what happens if I get 0? So 0 on top, answer 0. Move on to the next problem. 0 on bottom does not exist. Move on to the next problem. Today we're going to run into this. What happens if I get 0 over 0? So what we did was we continued with the problem, right? We tried to factor the problem. We tried to use conjugates. We tried to multiply. We did different things first semester. We saw this a lot. Today, I'm going to give you an easier way to do it. I think it's easier. I think it's an easier method, okay? Again, why didn't I show you this when we did it? Because you didn't know about it. You didn't have the proper tools to use it yet. And I'll explain when we get to that. So it's called, when you get 0 over 0, it's called what we call an indeterminate form. Because if I have 0 on top, that means 0, right? If I have 0 on bottom of a fraction, you guys said it's undefined, right? Not a real number. What if I have both? Is it 0 or undefined? That's why it's called an indeterminate. Is it 0? Because it's got 0 on top. That means 0. Or is it undefined? I don't know. So that's why it's called an indeterminate or indeterminate form. So indeterminate form just means 0 over 0. That's all it means. This one, the infinity over infinity is not 1. So if you get infinity over infinity, the answer is not 1 because it only works for numbers. Infinity is not a number. It's an idea. It's a theory. We don't know what's at the end of the number line. We don't know it's a big number, but we don't actually know what it looks like. So that's why infinity over infinity or negative infinity over negative infinity is also indeterminate. We don't know what it looks like. Okay, so that's when we use. The reason I highlighted 0 over 0, because that's the big one you're going to see. That's the one you're going to see most often. Okay? Okay, so what does L'Hopital's rule say? L'Hopital's rule says, oh, wait, let's actually do number 1. Let's actually do example number 1 and see if we see it. Okay? So let's go back to last semester, kind of, in our brains and figure out, how would we do this problem? If we were doing it last semester, how would we solve this problem? Because you did this problem last semester. What would we do?
First, we try to plug it in.
Plug in 2, right? Plug in 2 everywhere there's an x. Everywhere there's an x, I would plug in a positive 2. 2, 2, 2. Okay, so we do parentheses first, then exponents. 2 squared is 4, times 3 is 12. Minus 14 plus 2. And then on bottom I get 0. 12 minus 14 is negative 2. Plus 2, 0. 0 over 0. So it's not a DNE. This one's not a DNE because we got 0 on top. Last semester, what did we do? Well, we tried to factor the top, right? You tried to factor the top and see if something cancels out, something like that. That's what we did last semester. And that still works. But today what we're going to do is I'm going to give you another tool. It's called L'Hopital's rule. So L'Hopital's rule says if you plug in, just like you do that, just like you've always done, and you get 0 over 0, here's what you do. You're going to take the derivative of what's on top. You're going to take the derivative of what's on bottom and try it again. Take the derivative of what's on top. Take the derivative of what's on bottom. Try again. Okay? So let's do that. So the derivative, so let's rewrite the problem. So you get the limit as x approaches 2. So what would the derivative of the top be?
6x minus 7.
6x minus 7.
And then the bottom would be 1 minus 2.
Not minus 2, because minus negative 2,
it would
yes.
be
Just 1, right? Yeah, it would just be 1, right? That's the derivative. Repeat the steps. Plug in 2 now. We don't get 0 over 0 this time. We get 12 minus 7 over 1, which is positive 5. The limit is positive 5. That's L'Hopital's rule. That's L'Hopital's rule. Why didn't I show you that when we did limits? Because you had no idea what a derivative was. If I said, if we went back to August when we did limits, and I said, okay, then you're going to find the derivative, you would have looked at me like, what are you talking about, right? You didn't know what a derivative was. That's why I didn't show you back then. Okay, you had to know what a derivative was first to use L'Hopital's rule. Now that you guys know what it is, it's an easier method, I think. I think L'Hopital's rule is the best way to solve any limit problems. Okay, so let's go to number 2. The limit as x approaches negative 3. Plug in negative 3. So we get negative 3 plus 3. Then we got square root x squared, so negative 3 squared, minus 5 minus 2. So on top, we're going to get 0. On bottom, let's see, negative 3 squared is 9. 9 minus 5 is 4. So we get the square root of 4 minus 2. Square root of 4 is 2. So that would be 0 over 0. That's not a DNE. That means L'Hopital's rule. So now what I'm going to do is I'm going to find the derivative of the top and I'm going to find the derivative of the bottom. Okay? When you're finding derivatives, remember, you have the power rule, which we used on number 1. You have the quotient rule, you have the product rule, and you have chain rule. So all of those rules still apply. So we got to find the derivative of the top and the derivative of the bottom now. Well, the derivative of the top is pretty easy. What is the derivative of the top going to be? Positive 1. The derivative of the bottom is not hard, it just takes us a little bit longer. So what I'm going to do is I'm going to rewrite the bottom. So instead of a square root, what are we going to put in its place? 1/2. Yep. Minus 2. Actually, you know what? I should probably put it down here, give myself more room. Okay. Now I need to find the derivative of that. Well, the derivative of -2 is 0. So that part we don't have to worry about. So pretty much all we got to worry about is this part here. So let's go back. How do we find derivative of this guy? Which rule are we going to use? Chain rule. Yep. The chain rule says start on the outside. So this is going to be, this is going to be this something to the 1/2 power, right? Something to the 1/2 power means move the 1/2 to the front. The something on the inside stays the same. And then what do we do to the power? Subtract 1 whole, right? Now we got to do the inside, right? Yep. Now we got to multiply by the derivative of the inside,
2x.
Which is 2x. That is the derivative.
And then will we put it in like, move it down?
Yeah, so you can change it. You can, so yeah, so this guy right here, so you can go, so it would be 2x squared minus 5 positive 1/2, and then like that. You can do it like that. That's okay. Or you can leave it the way it was. The 2's are going to actually cancel out.
So we just get x over.
So on top it's just x, yeah. So you go x over, and then instead of 1/2 power, you can put back the square root if you want. Okay. That's the derivative. That's the derivative of the top. That's the derivative of the bottom. L'Hopital's rule says once you do that, plug it back in. Plug in -3 again. So when I plug in -3, I'm going to get 1 on top. And then on bottom, I'm going to get another fraction. I'm going to get, -3 over the square root of -3 squared minus 5. So -3 over the square root of, so -3 squared is 9 minus 5 is 4. The square root of 4 is 2. So that's all 2. So I have 1 divided by -3 over 2. So how do I do that? How do I do 1 divided by -3? How do I simplify that? So I have 1 divided by -3 over 2. How do I do it? Keep, change, flip. Yep. Keep, change, flip, or multiply by the reciprocal of the second one. Same thing. Keep, change the multiplication, flip the second one. So you get 1 times, oops, not 3 over 2, 2 over 3. So you get -2/3. Okay. Done. That's the limit. Okay. Number 3. Okay, so here's the thing with number 3. If you're going to use L'Hopital's rule, you have to make sure you get 0 over 0. So like from here, it would be a lot easier for me just to take the derivative of the top and derivative of the bottom. But we don't know that we're going to get an answer like this. We might get a number. You might get DNE. We don't know that until you actually plug it in. So what I want you to do right now is plug in -2 and see what you get. If you get 0 over 0, use L'Hopital's rule. If you don't, your answer is either going to be whatever number you get or DNE. Okay? So do some mental math real quick. So this guy, when you plug it in, -2 everywhere there's an x, you actually do get 0 over 0. That means L'Hopital's rule. If we would have got something over 0, anything, it would have been DNE. If we would have got 0 over something or any other number, it would have been that's the answer. But to use L'Hopital's rule, you have to do that first. 0 over 0. So 0 over 0 means now we're going to find the derivative of the top and derivative of the bottom. So we're just going to use power rule for derivative. So it's going to be 3x squared plus 2x minus 8. And then we get 3x squared plus 16x plus 20. Try it again. So if it's 0 over 0 again, find the second, keep finding the derivative, yeah. Find the second derivative of top, second derivative of bottom, yeah. Keep going until you don't get 0 over 0. So we get 12 minus 4 minus 8 on top. On bottom, we get 12 minus 32 plus 20. So yeah, you're going to get 0 on top and 0 on bottom. Find derivative again. So we're going to get 6x plus 2, 6x plus 16. So we get negative 10 over positive 4.
Yeah.
Reduce that, you get negative 5 over 2. That's the limit. Okay? Sometimes that'll happen, where you'll take the first derivative and you'll still get 0 over 0. Well, take the second derivative. Keep going until you get something other than 0 over 0. Okay? That's L'Hopital's rule. L'Hopital's rule is pretty cut and dry. I just wanted to give you different practice problems. So number four is a trig problem. Okay? And then you got some E problems, trig again, square roots, just practice. It's just practice for the different ones. Okay? So number 4, a trig. Still, you plug in 0. Everywhere there's an x, plug in 0. So we get 2 times sine of 0
Negative 5 hash.
minus sine of 2 times 0. On bottom, you get sine of 0 minus 0 times cosine of 0. Well, sine of 0 is 0, times 2 is 0. And then 2 times 0 is 0. Sine of 0, again, is 0. So you get 0 over 0 on top. Sine of 0 is still 0. Cosine of 0 actually is 1. This guy is actually 1. But since you're multiplying it times 0, it becomes 0. Okay, so now I got to find first derivative of top and bottom. Okay. So the first guy. Don't have to use chain rule for this guy because it's just 2 times sine of x. So the derivative of sine is cosine. So it would be 2 times cosine of x. Minus. The next one I will have to use chain rule because it's sine of 2x. So I have to do outside, inside. So the derivative of sine is cosine again. So cosine 2x times 2. Bottom is just sine of x. Sine of x, the derivative of sine of x is cosine of x. Minus. How do I find derivative of the last part, x cosine of x? Yeah, not chain rule, product rule this time. I'm not going to have to use the chain rule. I'm going to have to use the product rule because it's x times cosine of x. So product rule says the first times the derivative of the second. Okay?
0 times cosine.
So it would be 1, x. First term times the derivative of cosine of x. The derivative of cosine is negative sine. Plus. The opposite, derivative of the first is 1. Times cosine of x. Or just cosine of x. Okay. Plug in 0 again. Okay. Well, the derivative, or sorry, cosine of 0 is 1. So this guy is 2, because 2 times 1 is 2. Minus. Cosine of 0 again is 1, times 2 is 2. So 2 minus 2. Cosine of 0 is 1, minus. Sine of 0 is 0, times 0 is 0. Cosine of 0 is 1. So I got 0 on top. And then it looks like I'm going to have 0 on bottom as well. Okay? Find derivative. So I'm going to find the derivative. Okay. So 2 times cosine of x, I'm just finding derivative. So that's going to be negative 2 times sine of x minus. I move the 2 in front. Oops. Okay. So same thing. So it'd be negative 2 times the derivative of cosine. Well, I'm going to use the chain rule again. So that's negative sine of 2x times 2. So really, these guys would just be plus, plus. Derivative of cosine is negative sine of x minus. And then within there, I have 1. So you can do this. So in here, I'm going to have the product rule. In here, I'm going to have the product rule because it's x times negative sine of x. So x times the derivative of negative sine, which is negative cosine, plus 1 times negative sine of x. And then the last one is going to be the derivative of 1x cosine of x. That's just going to be negative sine of x. Plug in 0 again, and hope it doesn't give us 0 over 0. So negative 2 times sine of 0 plus, really this is 4, because it's 2 times 2. So 4 times sine of 2 times 0. The bottom, I get negative sine of 0. And then, let's see. So plug in 0. 2 times the tangent of 0. Tangent of 0 is 0. So 2 times 0 over 0. 0 over 0. Okay, so we got to find derivative of the top. So what is derivative of tangent? Secant squared, right? So secant of x squared. And then derivative of the bottom, it's just 5. Okay, let's plug in 0. 2 times secant of 0 squared over 5. What is secant of 0? Positive 1?
Yeah.
So 2 times 1, 1 squared is just 1, so it's just going to stay 1. And you get 2/5. Done. Okay. Okay, so last couple. So the next one is as x approaches infinity. So remember, so for number 8, let me go here. All right, so, oops, where is it? Here we go. Okay, so which of these is this? Is it bottom heavy, top heavy, or equally distributed? So we have on top, we have a natural log, a log, right? On bottom, we have a square root. Okay, so the growth rate, we're looking at the growth rate. Which one grows faster? Okay, so the top we said was a log, right? So there's a log. Which one, so what is the square root? Which one does square root fall under? Is it exponential? Is it a polynomial?
Exponential.
A square root is actually polynomial. Actually, square root is actually polynomial. Exponential would be like if the power is x, so it would be like 2 to the x power. If the power is an x, that's exponential. Square root, it would be 1/2 power, right? So that's actually polynomial. So the bottom is actually growing faster for this one here. The bottom is growing a little bit faster than the top. Well, if the bottom gets bigger than the top, that's bottom heavy. So the limit is going to be 0. That's just from last semester. Just a refresher from last semester. Okay? Because it's bottom heavy. Okay? Number 9. Top heavy, bottom heavy, equally distributed. This one's a little bit of a trick question. So it's a trick question because there is no answer yet. I can't tell if it's top heavy, bottom heavy, or equally distributed. Why not?
Because there's a negative power.
Because the power is negative, right? This guy doesn't belong on bottom. It belongs on top, right? So I'm going to rewrite this problem. X squared times e to the x. And there's a 1 on bottom because if there's always something on the bottom. So is it bottom heavy, top heavy, or equally distributed?
Top heavy.
Yeah, that's the only option, right? So if it's top heavy, the answer is either going to be positive infinity or negative infinity. That will be determined by, oops. So we're approaching negative infinity, right? So if I was to plug in a negative number, think of the biggest negative you can find, negative 1,000,000, negative 1,000,000,000,000, or whatever, and I square it, what would happen to it?
It would be positive.
Turn to positive, right? What happens if I put a negative number up here?
Move it back down.
It would move back down, right? And then would it be positive or negative?
Negative.
No.
Oh, no, positive.
It would still be positive. It would just be really tiny. It would be really tiny. But it would still be positive, right? Because like e, like for example, e to the negative 1,000. That would just move to the bottom, right? And it would be positive 1,000, right? Which is a really big number. So overall, this is a really small number. Not negative though. Negative powers don't mean negative numbers. Negative powers don't mean negative numbers. They just mean really small. So it would still be positive. So positive divided by a positive means I would get positive infinity. Okay. All right, last one. Last one, I want you to work on number 10. Work on number 10 and we're done. Okay, so plugged in 0 over 0, plugged in 0, I got 0 over 0 to the original. So I took the derivative. So the hardest part about this is just finding derivatives. That's the hardest part, and you guys have been doing that since last semester. So that part is review. So I found the derivative of the top. I had to find the derivative of square root 1 plus x. The derivative of negative 1 is 0. The derivative of x over 2 is 1/2, negative 1/2. So that's where that comes from. Okay. So now I'm going to plug in 0. So I get 1 over 2 times square root 1 plus 0 minus 1/2 over 2 times 0. So I get 1 over 2 times the square root of 1, which is just 1, minus 1/2 over 0. So it looks like I'm going to get 0 over 0 again. So find the derivative. Well, I guarantee you, you're not going to have to do anything after next because the derivative of the bottom is 2. So you're not going to be able to get 0 on bottom if you find derivative again. Derivative of the bottom is 2. So we got to find derivative of this guy. So we're going to use the chain rule again. So I'm going to multiply negative 1/2 times 1/2. You get negative 1/4. Subtract a power, you get negative 3 over 2. And then the derivative of negative 1/2 is 0. Plug in 0 again. So we get negative 1/4, and then we get 1 to the negative 3/2 power. Anything, 1 to any power. Doesn't matter what power it is. If it's 1 to that power, it's just going to be 1. So it's really just negative 1/4 times 1. 1 to any power is always 1. So you get negative 1/4 divided by 2. Well, if you have 1/4 and you split it into 2, you're going to have 1/8. 1/8 and 1/8, so negative 1/8. That's about as hard as it'll get. Like I said, the only hard part about that is derivatives. And you guys have been doing that since last semester. Since September, you guys have been doing derivatives. So, yeah. Okay. All right. Okay, so tomorrow I'll give you the practice. We'll do the practice in class, and then we'll go from there. Okay.